Okay. All right, so let's start. Maybe with some luck we'll go through quick. Good news or bad news, whichever way you look at it. I have no Kahoot for this one, so I guess that's okay. All right, so we won't be holding around afterwards, so maybe we finish a few minutes early today. All right, variable scope and parameters, which means I didn't actually need to cover parameters yesterday, last class, but I did, so that's fine. I like covering stuff in advance. It means that we can kind of turn to a review to remind you, because I have had issues with this before. All right, so here we go. A couple slides first, then we can flip over and we can do a bunch of programming experiments because it'll be a lot more interesting. All right, so what do I mean by variable scope? Okay, obviously everybody knows what the word scope means, variable, but maybe you'd have no idea what the word scope means. Everybody understands what the word parameter means, so at least that's good. So yeah, it was about default parameters. However, variable scope, we have to come up with something new. Okay, so off we go to get started. So a couple of sections out of the book. All right, so the word scope basically means where can a variable be accessed from. Okay, and here's a very, very important rule. Luckily, Python is not as strict about this as some languages, but basically when you create a variable, it lives for a certain amount of time, then goes away. They don't live forever unless they happen to be stored in a certain location. All right, so the easiest way is probably to get over and actually look at the examples. So here, we'll pop in an example. We'll try a couple of things. All right, so what I've got here is I've got an example. I'll just steal the one directly from the text. Okay, so here we go. This is something called calculate text width. All right, just to give you a bit of a background, I was trying to come up with some example that would make sense because it turns out a lot of functions, unless you have lists or other collections, they're kind of dull. They're really hard to justify what we're doing. This one I came up with. So the idea was that, okay, I was looking at exactly something like PowerPoint, and I said, hey, you know what? If I type a bunch of characters as a string and I try to make it appear inside a box, the box has to be a different size depending on the font size. Okay, and that's exactly what it is. So the idea is that, okay, you say, okay, this is the text we're interested in. You pass in the size of the font. You pass in the type of the font. It could be Calibri, Times New Roman, Consolis, all of these types of things, and it'll return back a number. The numbers doesn't mean anything to us, they're just numbers. But basically, the longer the text is, the wider the box you'll need. All right, so it's a function. Okay, you can see that a couple of interesting things are going on here. I suppose we better talk about them because I didn't mention them last time, although it should be here. Okay, I'm gonna have to ask, okay, well maybe what we'll do is we'll just try it a couple of times and then I can ask the question. All right, so to test my function, no problem. All I have to do is just call it. So maybe it's the width of the box. I'll put it into a variable called W. I'll call calculate text width. Okay, and I know it's almost here. We'll say hello world, and we'll say that it's 12 points, and Calibri is the font type. Okay, and I'm just going to print W. All right. Again, I just want to run it a couple of times just to make sure everything is okay. So yeah, if you say hello world at 12 points, it should be 66, whatever that is, maybe in points or millimeters or something. But if I make this a lot longer, well, then it becomes 144. It kind of makes sense. And likewise, if I make this, say, 50-point fonts, then it obviously becomes a very, very big box as well. That's all I was trying to do here. All right, now I'm going to have to ask a very, very important question, and that is, what is the type of the thing that's returned? Somebody said float, somebody said string. So does this look like a string? 275, and okay, how could we tell if it's a string or not? Okay, if we add 1 to it, and it's a string, it will not work. Okay, but it'll actually add 1. Okay, and yeah, it is a float. If you really wanted to know, what we could do is we could always put in a type W and it will tell you it's a float. Okay, very good. So it is a float. Now, somebody yelled out and said string. Why? You're just guessing? Okay, where? Okay, give me, somebody's talking about the first. Tell me a line number. Give me a line number we can look at. Line 13? 14, okay, good. So this takes the, this returns the total width after being rounded. Total width is this times this times this, et cetera, et cetera, et cetera. And I'm pretty sure if you look up what rounding does, I'm pretty sure it returns a float. Okay, that's fine. That's not what I'm interested in. We know it returns a float because I can see it. Somebody said a string, and I want to know why you said it, because you're not wrong. Take a look at line number 6. That's the one that comes after 5 and before 7. What's it returning? String. Hang on. Okay, so how do I get a string back? Well, according to this, if I ask for, say, a negative font, take a look what happens. You see, if I run this, I actually get back a string. That's the W. That's the type of W, and I print W. Yeah, it pops up this way. All right, now, this is a bit of a faux pas. I did this on purpose so I could talk about it. All right, in the world of Python, is it allowed to sometimes return a float and sometimes a string? Well, apparently, because I just did it. So it's not a problem. If this was a course where we were using Java, that would be completely disallowed, because in a strongly typed language, you say this function will return a string, or this function will return a float, and that's it. You can't return anything else. So Python kind of gives us a lot of flexibility to do things that are, I'm going to call it slightly sketchy. It works, but it may not be the best design, because unfortunately, you see, when you call calculate text width, remember what I said, the reason why you put things into a function so you can reuse it later. If somebody says, here's this really cool function, and it always returns a float, and you pass in some values and it gets a string, it's like, wait a minute, now I've got a string instead of a float. I can't do things with it. Okay? Like, for example, if I tried my little attempt just a few seconds ago and I said add 1 to it, I'm going to get a problem when this runs, because I won't be able to concatenate a 1. This is one of the downsides to Python. There's so many upsides. That's why we end up picking this language. And if people say, oh, I hate Python, no, let me clarify what you hate. You hate writing programs, yes, but trust me, you don't hate Python. Okay? You might really not like the questions we ask. You might not enjoy writing programs, but trust me, Python is not your enemy here. It's actually helping you quite a bit. Okay, by allowing you all of this flexibility. All right, so if you want to complain about the right dimension. Okay, I do agree it is difficult. All right, but in any case, here we go. So this is a bit of a surprise, because functions can return anything. It just depends on whatever shows up. All right, so why did they do this? Okay, well, they did it because they wanted to make sure that whoever called the function knew what was wrong. Okay, which is fine if you print it, but if you're trying to use it in a calculation, then it goes really, really bad. And this is a very common thing. You will see this. It will happen a few times. A very common technique, and I better say it because I don't think I've seen it here in the slides, but I think it needs to be added. When things go wrong, very, very frequently what people will return in Python is they will return a certain value, and the value is called none. And that's kind of like, hey, there isn't actually a value here. Quite often we use it for, hey, you know what, there's a mistake. So yeah, if you run it, it shows up as a none. But just in case you ever see a question, because I think you'll see them probably in the labs, where it'll say, okay, do this type of a calculation, but if the input is bad, please return none. Okay, and that's what it means. And by the way, that's very different than the string containing none. That's a string. Okay, the other one is actually a certain type in Python. Okay, sometimes I will put questions. You don't need to make the decision about what to return, again, because we don't get you the design functions in this course. We simply say, you provide the implementation for the function, and here's what it's supposed to return in these cases. So we make that very, very prescriptive to say, this is what's happening. But I have to say things like this because, well, I know you'll go to other websites, you'll look at videos, and quite often the complaints that I get is, yeah, but they're doing things in the videos that are completely different than what you're doing. No, they're still doing Python programming, but sometimes they might have a very specific style where they say, okay, we're going to return this in this particular case. That's all I'm trying to cover here. Okay, so there we go. That's the first piece up. Now, the whole reason why I'm here, oops, okay. Okay, all right. I called calculate text width. Oh, All right, no problem with this one, right? Yeah, this gives a number. All right, now normally what we were doing is we were taking the return value and putting it into a variable called w and we're printing it. But here's my question I would like to ask is, what if I just did this? What if I said print total width directly? And what I'm referring to this one right here, okay? There we go. So in other words, I'm not going to bother with that return business because, well, it's ugly, right? So if I just trash that, now I've saved myself a line of code. I mean, everybody wants to save lines of code, and I didn't do it. Why? Now, I suppose you could answer with, well, because it doesn't work, but that's actually not a good answer. Yeah, it actually will be undefined. Okay, here, we'll let it run. Officially it's a name error, and it says that total width is not defined. Yeah, there is no variable called total width. Why? Because it's inside the function. Remember what you can do with the function. You take the function, you can drop it out anywhere else. And here's the number one rule. This is called variable scoping. The variable called total width is a local variable to the function. All right, and likewise, okay, since we're here, how about if I print text? Yeah, it's also a local variable. So parameters are considered like local variables. If you try that, parameters are local. Any variables you create inside here, so font size, font type, okay, this total width, these are all local variables. At the end of the function, all of the local variables are tossed out. They no longer exist. So even if they had something, they'll never get it back again. Okay, I can even demonstrate that in a second. But then once the function returns, that's it. You don't have access to anything from inside the function. All right, so here we go. That's what we had, one run. Okay, that was the issue that we had. Just one extra thing that I wanted to do. Let's not try printing it. Let's stick it back into a variable called w, print w, just so we add a number. All right, 66, okay? Now, I'm gonna ask a question here. Now it'll print. Yes, because we are accessing from inside the function. However,
it comes before it.
Yeah, it comes before, and you already know you can't use a variable before it's being set to something. All right, so there you go. It cannot access local variable where it is not associated with a value. It's a slightly different message than what you're used to, but it's actually pretty close. So the problem is that when you start the function, all of the local variables get created as you need them, and when you try to print on line number 5, well, you haven't actually set the value yet. Okay, now I'm going to write a little hypothetical program here. Okay, and I have to be very careful about what I'm saying. Okay, will it work now? Yeah, it'll work now. And what's the return value when I print it at the very end for W? Yeah, it'll change. It'll be 66, just like what we had before. Okay, now I can't demonstrate this, but what I can do is I can at least say something. Okay, and I am going to just add one extra item in here. I'm just going to say hello, just so I can talk about the tracing. Okay, because that's very, very important. I can't run this because I'm going to have a whole pile of troubles. I won't be able to explain what I'm trying to cover. But here we go. Let's run the program. Okay, trace tables. I know that you saw a few trace programs over in infs 1101. We don't do a whole lot of this here, but every now and then I need to. All right, so from there, you know that I need something called a line. So this is going to be my variables. It's going to be the live values of variables. All right, I've got a variable called line. Okay, this is going to be the line number that I'm working on. I've got a variable that's called text. I've got a variable called font size. Oh, actually, you know what? I'm not going to say this yet. All right, when you start the program, what's the very first line that gets executed on my program right now? 20, okay, very good. All right, so what happens is when I call the function, I immediately get 3 variables. I get a variable called text, and what's the value of text? Hello world. Okay, hello world. I'll leave it into quotes. I get a variable called font size, and what's the variable? What's the value? 12. Okay. No, that was pretty easy. And I've got this thing called a font type, and that is going to be Calibri. Here we go, Calibri. Brie. All right, there we go. Oh, and when I make the call, I basically jump up to line number 1. Okay, so line number 1, these variables appear. They weren't there before. They only appear because I call the function. That's very important. Actually, I know exactly what I'll do here in a few seconds just to say that, yes, I can even show in another simulator. All right, what we do is we go through line number 5. It does a print. We jump to line number 6. That will make a brand new variable called total width. It'll be set equal to 4. We're then going to go through a bunch of other things. I'm not going to go through all these, but you'll see it will end up going through, let's see, it'll go to 7, then it'll go to 8, then it'll go to 10. It'll end up going to 12 and 13. Okay, I'm not going to worry about all of these things, but let's suppose we're at line number 17, and we already know that the total width is now set to 66. Of course, at this point, I now do a return. Where do I go back to? So the line number changes. Where do I go? 20 again. Oh, sorry, 20 again. But most importantly, all of these variables right here, these were variables inside the function. Here's what happens to the variables at the end of the function. They all go away. Okay, now the reason why I have to say this is because on line 22, remember what happens. I call the function on line number 1, and I get 3 variables again. What about the variable called total width? Gone. It doesn't exist because it was cleaned up the previous time. Now, I remember suddenly I've got like a very, very cool little thing. Hopefully it's available. It's called a Python Visualizer Online. Very, very handy if you're trying to figure out what's going on. Okay, so let's see. Oh, it's all different from what I've had before, so I hope it still ends up working. This is what I get for not checking things in advance. So it's going to go off. It's going to do some calculation. I hope this still works. Maybe it's a different one than I want. Okay, well, that one thinks about this. Online code chef, online Python. Oh, this is not so nice. Okay, let's see, did they come back? Okay, yeah, this is fine. All right, so this is now allowing me to step through each of the steps. So take a look. You see the very first line that happened was line 20. I come, and what I do is I make a function call, and I'm currently on line number 1, but you just notice that I ended up with a bunch of variables. I go through, I now have a new variable called total width, just because I did that. And very, very importantly, once I reach the end, here you go. So now I got a total width, I got an extra variable. The very next step, I return, and of course, all those variables disappear. Okay, so variables that show up inside the function, they're there just temporarily. All right, good. So a big, long explanation for something very, very simple. Okay, so now you got the idea. Okay. Yeah, you got a variable inside a function, you can't reach in and modify it, you can't get it. All right, next one up. Okay, something now completely different. All right, so we've got this. Oh, I forgot to put in estimate line count. Okay, so this idea was, okay, you have a text box, how many lines of code are we gonna have? So what I'm gonna do is it returns a line count, so I'll call it LC for line count, and I'm gonna say estimate line count. Okay, we're gonna have some text. Okay, lots of text. Care about this. Font size of 12, that's fine. And I'm going to print LC. All right, again, it's how many lines of code would you have? Okay, how many lines would you have in the box? We'll say 5. What the function is doing is irrelevant. Okay, what I'm really interested in right now is a couple of questions. All right, the first thing up that I'm going to have to ask, and I probably should have modified some things first, is right here at the very end, I want to try calling print page width. And I would like to ask, am I going to have a problem trying to print the page width?
No.
No. Why?
It's outside the
Because it's outside the function. Very good. Oh, one of the styles that you will notice that I will always do. You'll notice that my functions always appear at the top, and my main code always appears at the bottom. Okay, that's a very common thing that I will end up doing. So sorry, it wasn't like this here. So here we go. We just go ahead and run it. Okay, so here we go. 5 and of course 100. Okay, excellent. That's fine. All right. So now, why are we doing, or sort of, why do I do this? Old programming languages, we used to have to do it. Python, you can put your main at the top and the functions at the bottom. Really don't recommend it. Sometimes what I see, especially from 1101 students, so you're not no longer 1101 students, I will see define a function, call it, define a function, call it. This is not the way how you build functions. You build all your functions in one place and then you write your main program so you can see what the main program is doing. Okay, so don't define functions in the middle of your main program. Very, very confusing. All right, now the reason why I wanted to pop this up is because page width. Okay, you see something new that we haven't talked about yet, and you probably haven't seen before. Yeah, global. Oh, what is this? All right. So remember the rule a few minutes ago, is if I have a variable defined inside a function, from the main, I'm not allowed to touch it. Okay. Okay, so now my question becomes, am I allowed to do this? Get rid of that before I get confused. What do you think? I mean, there's some magic word in there. Maybe it has something to do with it. All right, so here's what I'm going to do. Let's clear the screen. I suppose there's one of two things. It's either going to print inside the function, and what do you think the page width is going to be? If it works, okay. The other possibility is maybe it just doesn't work and I show up with something like a name error. All right, so here we go. Yeah, when I run it, yeah, you see it. Okay, so here's the rule. If you are a function, you can access a variable that comes from the main. Okay, yeah, you can access a variable that comes from the main. Okay, it could be useful, usually not. Mostly I'm showing you this because there's like a lot of trouble with it, but I'll explain the times that you might need it. In this course, you'll probably never be asked to write something using a global variable, but I'd like to demonstrate it because you might find something online that suggests doing it, and it might not be a good idea. All right, but in any case, so yes, the rule is you have access. If you're a function, you can reach outside, but if you're a function, nobody can reach inside. That's kind of the rules. So therefore, it must have something to do with this magic line right here. So if I remove that line, what do you think? Okay, so notice that I got rid of the line called global page width. And my question is, what do you think? Same output, or will we see something different this time? Yeah, it seems like a name error, right? Okay, so here we go. You run it, and no, it completely works just as well. Oh, okay, so this is a bit of a surprise. Even without that word global, yes, the rules are still the same. You can reach outside of a function and get any global variable that you want. But if you're a function having your own local variables, nobody else is allowed to touch them. Well, can a function reach inside another function and get the variables? No. No. So nobody from the outside is allowed to get the variables inside the function, but the rules in Python are you can reach outside. Okay? Why? That's the way they designed the language. I'll give you one example why you might want this. I'm not saying it's a good example, it's just I will provide one example. All right, so there we go. Let me now do something a little bit different. Let me get over to here and undo this. Let me get rid of my bar. All right, here we go. Okay, line number 9. I'm modifying a variable called page width. But the line before it says it's a global variable called page width. So inside this function, it is called this. Now, we know that there's no issue in here. Well, at least I assume that there's no issue. I mean, we printed it a few minutes ago, no issue. Let's look at this because, okay, remember, it starts at 14. I call a function, and something that you learned from your 1101 course is that when you call a function and you change the value of a parameter, it has no impact on the variables outside the main program. Okay, so unfortunately this one, okay, I suppose the best thing to do is just to go ahead and let it run. You'll notice something that it does, and that is, yeah, it actually is allowed to change. Okay, why? Because I said it was global. So what I'm doing is I'm saying on line number 8, so if you were to trace through, you know, okay, very first line that happens, line number 14. Line number 15. Line number 15 will be a jump to line number 3. Line number 3 will set up the 2 variables. So you'll go to line number 8. Line number 8 says, okay, there is a variable out there called page width. It's out in the global scope. And then when I reach line number 9, I try to modify it, but because I already said it's in the global scope, yes, it's allowed to modify it. Now, I don't talk about usefulnesses of this or anything else, but there's a bit of an issue with this one. Okay, you see, what I did was I called a function, I got a return value, and something else happened that I didn't expect. This is actually called a side effect. Okay, because you're expecting one thing and it did something else. Do side effects sound like it's something that you want? No, generally not. Like for example, if you take some medicine because you have a headache and you check the side effects, it usually lists all kinds of really unpleasant things, like it may cause headaches. Seriously, pain medications sometimes do this. It may say it may cause drowsiness. It never says this will cause tremendous excitement and for you to be smarter in programming. That would be an excellent side effect, but it never happens, right? Because they don't list it. That's why they called it a side effect here, is because it's something that was unexpected and maybe not something that you wanted. All right, but I got one more weird, quirky problem. Okay. Remember, that line was completely useless, right? This version, it doesn't modify. And here's where things get a little bit weird. Okay, we already know the process. Line number 14 creates a variable called page width, but it's a page width variable that's out in the main program. I make a call to line 15, I jump up to 1, and when I hit line number 9, I see page width is equal to 30. Okay, but because it's not global, it says, oh, they want a small local variable. Okay, so I'm modifying my own local variable. All right, scoping rules can get a little bit funny like this. Generally, what I say is if you really need a global variable, then you always make sure to stick the word global in front of it. Even if Python doesn't require it, it's one of these good practices because this way you remind yourself it is actually global. If you do want a global variable, you probably want to make sure it's very, very clear that you want it. Now, I suppose the real important thing is okay, here I got a slide. There we go. So it's a comment about a side effect. Normally you don't want them. If you do ever use them, you should include the word global. Now, why would a programmer ever want to use a global variable? And it's pretty funny because if you go and you talk to any program that's been around for a long time and you say something about global variable, they'll immediately freak out and say, whoa, no, you can't use global variables. They're all bad. Why? Because they've probably been burned by calling a function and having something else change. And I've had this same experience. Remember, this is not a big program, but I've worked on programs before that. Our system was about 100,000 lines of code. You call a function and suddenly this variable changes and you had no idea that it was about to change. That's a big deal. And you say, well, who changed that? I didn't change it. It was 25. I called the function. Now it's 45. And you say, yeah, just look in the function. Unfortunately, you look in the function, it calls another function, which calls another function, which calls 20 other functions. It's hard to track down. Global variables really cause really, really unpleasant spidering is what I would call it, of issues because you can't figure out who's changed what. Okay, so generally you try to avoid it. I will never in this course ask you to write a function that uses a global variable. I think in one of the labs next week you might have to justify why one particular item happened, but I still include it in the course, even though I never ask, just in case you see some mention of it on some site that you're learning Python from. Okay, but generally the rule is in this course, you won't be asked to write use global variables, but at least now you know what they are. All right, but I will give you one example. Okay. Okay, we need a loan calculation again. Okay, I should have had it from last time. If I've got the loan calculation function available, I will pull it back. If I don't, I'll make one up. So give me 1 second. Looping, recursion. No, I think I erased it all. Which slide is this? 7, so I'm looking for number 6. Okay. We'll make a function. Okay, here we go. Remember this one? Loan payment? Okay, takes a principal, it takes an interest rate, and it takes a number of months, or a number of years, I think. Okay, and all that I'm going to do is I'm just going to do a silly little calculus. I'm just going to take the principal and divide by years, and I'm going to add 5,000 or something. I know it's not correct, but I don't really care. Okay, it's just a function. All right. Oh, you know my opinion about using I, right? Okay, we'll fix that in a second. For and I. Okay, it's the world's silliest program. Well, not the world's silliest. We'll make sillier programs yet. All right, I won't even print P, I'll just print done. Okay, congratulations. What does the program ultimately do when I run it? What does the user see? Done, very good. Okay, it's a silly program, but I've got a really important question. How many times is the function loan payment called? 4, yeah, 40 times. How do you know? Because I can count it. I say it's a for loop. Oh, and by the way, if you ever wanted, okay, here, make it different. If you ever want to have a for loop and you don't know what to call this because you're not actually using it, there's a very standard thing people do in Python to use an underscore. It's just a placeholder. You don't have to use it. I would prefer that you call it something else like duration or counter or something. It makes a lot more sense. All right, I want to change my program a little bit, okay, because I need a situation. All right, here we go. Let's have, okay. We'll do this one. While true, what are we going to ask for? Let's ask for a principal, okay, int input, enter the amount. Remember this from last time. I'll even call principal. Okay, and I'm not even going to print it, but I'm going to put an importance check in here. I'm going to say if principal is equal to -1, I'm going to break. Okay? All right, let me do a quick little check. Okay, enter the amount. Nope. Enter the amount. Okay, very good. And when I press -1, okay, good. That's exactly what I want. Let's clear the output. Now I'm going to ask a very simple question. How many times is my function loan payment called? Yeah, you can't actually tell, can you? Okay, very good. Because we've got ourselves a loop which we don't know until the user actually does it. Now, if I asked you, I want you to count how many times it's called, here's what you're going to do. You're probably going to have a counter. You're going to set it here, and you're going to put a counter plus probably right here, just after this has happened, or just before, or does it matter? Okay, well, whichever way you're going to put it. Okay, and you would have an increment, and then at the end you'd print it. Okay, I'm going to give you a different way. I'm not saying this is a good way, but I'm going to give you a different way using global variables. And I actually wouldn't want you to do this, but we've got it. Okay, here we go. No, just right here. The call count. Okay, 0. Yeah, makes sense. Okay, that means I got a global variable. What did I just do? Yeah, I incremented, okay. And at the very end, okay, see what I've done is I've used the global variable to modify the counter so I don't have to in my main program. Why would you do that? Well, because maybe I'm calling from like 20 different places in a program and I just need to know how many times it was called altogether. Remember, big programs, 100,000 lines of code? Okay, yeah, I know, you'll say, well, just do a Control F. No, because remember, when you get 100,000 lines of code, you don't keep everything in one file, you break into a bunch of files. Okay, well now that's a more difficult problem. But to make it even worse, you usually don't keep them in just a bunch of files in one folder, you stick them into a whole bunch of folders. And sometimes you take them and you put them onto different computers because you got a really big system. So this idea of simply doing a Control F to find something, it's not going to work. But that solution right there, this would actually allow me to count. Here, just to show you that it works, okay? So, all right, and -1, and yeah, it comes up with 5. That's one reason why you might use one, okay? I don't have much else, but I do have this as one possibility. I use this occasionally. It's mostly kind of for my own internal purposes. That's one reason. Okay, let me give you the other reasons because I do see I've got a slide on here. Okay, so here's a slide about why do programmers use global variables. The first one is to maintain state. All right, so the word state means being able to retain inside a function what was going on. Because remember, at the end of a function, your variables go away. If you wanted to retain them so that the next time you call, you have the same state, or the same values of the variables, you can use globals. I don't get you to do them here. All right, but it can be necessary in some cases and helpful in others. And probably the biggest thing that people use it for is the second one, which I've said before many times. Yeah, laziness. Because if you don't have to pass in a parameter, hey, excellent. Oh, until it isn't. Okay, so if you have a one-off program, you're just trying to hack something together, it's not a big deal. I use them occasionally because, well, I'm in a hurry. But if I'm trying to deal with an actual piece of code that I know I'm going to have to use a bunch of times, I avoid them because I know what pain they cause. Okay, so don't fall for the laziness trap. It's kind of a little bit easier. All right, so I got something in here where it's basically doing the same thing. Okay, all right. The good news is the default parameters we actually covered already. We did it yesterday. Remember, if I were to make a function calls, here's my estimate line count again. Sorry, let me pull this up just so I can remind everybody what it is. Then I guess this is good, just in case somebody wasn't here yesterday. Okay, and don't worry, we're nearly finished already. I did say it was going to be easy. I'm going to get rid of the global variable because I don't need it. Okay, and here we go. This is going to be the LC is equal to estimate line count. I'll pass in some text, and I'll pass in a font size of 12, and I'm going to print LC at the end. And here, of course, this is the point where I really need to work this out, is if I print inside and font size. Okay, so my question isn't about what the value of LC is. My question now is, what about font size printing on line number 6? If I run this program right now, what does font size get printed as? 12, okay. Oh, and we got a page width, whoops. Oh, okay. It's good I didn't ask for the other one. Okay, 400, there we go. I just don't want it to crash. All right, so just ignore the second number. We don't care about that. All right, so the next one, of course, is we did this the other day. If I say that the font size is 34, when we jump inside the function and I say print the font size, what's the size of the font?
34.
34, okay, good. And, of course, as we did the other day, what happens if I remove this statement or remove that argument? Yeah, it still works because I've got a default value. Okay, and by having the default value, it picks up the 12. So if you pass in something, it becomes the value. If you don't pass in anything, you're allowed to do it, and it will pick up the default. And one final thing, if I remove this, because I thought it was so fun the first time, would this work? And the answer is no, because there's no default value for text. But there could be. There could be. So now this function would work. When I run this, everything will be fine. If we looked at text inside, it would actually contain the word Python. Okay, so yeah, they can all be default values. Okay, so that was already done. Nothing about this. Let's see, I don't think I've got too many more pages. Oh, here we go. All right. go back again because I just used it. Okay, I need the loan function once again, but I'm going to set it up so I'm going to ask the user for 3 amounts. I want to call the loan function. Okay, all right. So write a program, ask the user for three amounts, call the loan function each time and print the amount. Okay, I don't even care if I get the right function or not. All right, where do I start? Do I start with the function or do I start with the loop? Because you know we're going to use a function to call it. Do I start by writing the function or do I start by writing the loop? Yeah, okay, good idea. Why? Well, because if the function isn't there, you can't call it. I can't even test anything at this point. Okay, yeah, very, very good. But you know, I could write a loop because I can set up something like this for, I don't know, okay, counter in range 3, and I can ask for the input statement. Okay, I can do this first and then figure this out afterwards. But you're absolutely right. Start with the function. Really good idea. Loan payment. All right, we know the loan payment's going to take a principal amount. We know it's going to take the number of years. It's going to take the rate. And what do I put in here? I don't know, but it's in another document. I'll find it later. Okay, so let me just leave that. Okay, I'll fill it out in a few minutes. All right, let's write the other part that I know how to deal with. Okay, for counter in range 3, I'm going to ask for the amount. I'm going to ask for, let's call it int input enter amount. Okay, and I'll just hard code the years to be 4 years. I'll hard code the rate to be 6 years, so I don't have to ask the user. And of course, I'm going to call loan payment. Oh, in fact, I don't have it yet, so can I test this? Remember, I've been pushing this all along. You don't want to write a big, long program and find out that you've got all kinds of syntax errors. You want to write a few lines at a time and make sure that you've got your program running. Okay, so my main program. Should the main program work? Like right now? Why not? I mean, I know it's not complete. I'm asking, can I run the program? And what I want is I want the program to ask the user 3 times. Remember, that's why I said problem decomposition. Will the main program, and I will just highlight and I'll say just the stuff right here, will this work? Yes. Yeah, actually it will. Okay, so how come people are saying no? Oh, the function, yeah, okay. We got an issue, don't we? The function problem. Okay, you know what? I got an easy thing for dealing with a function. What if it just wasn't here? Yeah, okay, good. But you can see the reason why I might want the function. But the issue is right now, if I try to run this, I guess I better ask what the question or what the result is going to be. So people said no, so obviously we're talking an error. We're talking a runtime error or syntax error. Nobody knows. Okay, well, let's run it and see if we figure this out. Yeah, okay, it shows up as an indentation error. It's actually a form of a syntax error because when you have a function, you must have at least one statement. You must have one statement. Okay, it doesn't matter what the statement is, but it's got to be a statement. Sometimes what I will do when because I will write up a function, I'll say, let me get the main program, then I'll come back and I'll fill this in. All right, sometimes I will do stuff like this. Okay, I'll use reality is what I type. Okay, yeah. If the function ever gets called, just prints blah. Yeah, I know that's not calculating the loan payment, but you know what? I can now test my program. I can find out whether or not the inputs are asked 3 times and the program stops. Okay, but it's not realistic, but it's enough to get me started. Okay, here's another thing that I sometimes do. I just return just some random value. Why? Well, because I need to have something. I can't have nothing. I need to have something. And again, it's just enough so that I can run the program. But you see, what I can do now is I can actually start to call the payments. I could actually say PMT, and I can actually get a loan payment and start to work things out. That's why I do it. So these little placeholders, you'll see me use it all the time. There's a placeholder that sometimes people use in Python, and it's the word pass, which is why when you try to count how many people are passing, it turns orange. It's actually a reserved word. What does it do? Absolutely nothing. Then why is it here? Because we need something. Okay, that's the only purpose. If I call the function, what happens? Well, nothing. So here we go. PMT is loan payment. We'll pass in the amount, we'll pass in the year, we'll pass in the rate. I don't even care if these values are the same. Yeah, everything continues to work. What's it doing on line number 2? Absolutely nothing. But it has to be there. There has to be something. I will use it occasionally. Most of the time, I put in stupid little print messages or return none or something. Okay, just to let you know this happens. All right, likewise, we got another example that I've got right here, which is score. Okay, sometimes I see this. This is the reason why I put this in. Okay, somebody asked for a test score. Okay, and what you want to do is you want to count how many passes there are. Okay, so right now we've got this, and what I'm going to do is I'm going to ask the question, if score is bigger than or equal to 60, what do? Passes goes up by 1. Okay, obviously this will go into a loop, okay, so no problem. Yeah.
In the previous one, you put print for in line 2, but it didn't print.
I never called the function. That's why it didn't print.
Okay.
Yeah, I didn't print. I didn't actually call the function at that point. If I called it, we would have seen it. Okay? All right, so that's fine. That's exactly what you want. You know, sometimes I get students who are in a lab and they'll say, how do I not do something? Like, for example, I'm going to come up with this one right here. If score is less than 60, should I do anything with passes? No, but maybe you want like an else, and you want to say, okay, in this case, the passes goes up by 1. What would you do here? Absolutely nothing. Sometimes you will see code like this. Is that a good approach? No, you'd probably write it the other way. But sometimes I will do things like this because I don't know what to do yet, and I'm working through an explanation. Okay, so I will do these types of things. Okay, here's a case in point. Okay, while true, score, I guess I should have done this in the first place. Now I got the idea. I know exactly what to put this as an example. Enter score. Okay, if score is equal to -1, break. Okay, now we have other things. Okay, if the score is bigger than 60, I don't know what to do yet, but I know I'm going to have to deal with it later. All right, you see, this way it allows me to continue to work the program, and eventually you replace the word pass. So here's what we use pass for. You use pass for debugging and for writing the code, but when you're finished, normally you write your code so it's all gone. Okay, I'm just letting you know, and again, in case you see this somewhere else or you see me using it. It's a placeholder, that's all that it is. Usually I will do something else like print question marks, okay, but this is kind of, it's part of the Python language, it's what people do, so I think it's worthwhile to say. All right, we got a final thing. Okay, then we'll be done. And as I say, there's no Kahoot today. All right, what I've got is a function called calculate area. Okay, what does it do? Yeah, you managed to figure that out? Wow, really? How'd you know it was an area of a rectangle and not the area of a circle? Because it said right there, I saw all these green letters and it actually described. How many parameters does it take? 2. What's the first one? Length. Is it an integer or a float? Yeah, it actually mentions it's a float, isn't it? Yeah, this is very prescriptive. What does it return? What type?
It returns a float.
It returns, you got all this from that piece of information that was given to us. You can't actually pick most of the stuff up from the code. You could guess, but you can't actually tell, can you? Okay, you would know, I mean, you could probably take a guess it has something to do with because you're multiplying length and width, but you don't know if it's supposed to be integers, you don't know if it's supposed to be floats, you don't know if it's supposed to be strings, who knows what goes on. What if somebody passes in a negative value? Does it return anything other than a float? And the answer is, well, not according to that thing that's inside this green. Now, we've seen the green stuff before. I called it a multi-line string, and to be honest, I probably should have used 3 single quotes because I think it's easier to spot, because otherwise it looks really bad, but it works with double quotes as well. I described a triple quote string as a multi-line string. Okay, yeah, that's a multi-line string. A multi-line string that appears inside a function has a special name that's called a docstring. Okay? And what it is, it's a comment that describes what the function does. Okay, what's its point? All right, the point is not so obvious here. The point will become a little bit better if I pull over idle for a second, okay? And it doesn't mean that we can't use the online interpreter. It just is not quite as nice. So here we go. We've got this function. We'll call it, okay, we'll just call it r is equal to calculate area. We'll pass in 40 and 5. I'll print r. That's not a big surprise. What am I expecting to see? Well, I picked it easy. Yeah, 200. Okay, good. All right, so let's run it. Okay, so here we go. It runs. Sorry about that. This is a problem with idle. It pops open in the other window, but here we go. There's the 200. Excellent. All right. Oh, what was the name of the function? Calculate area. Okay, there's a function. Oh, notice that? It turns purple. That means it's a built-in function. If I had no idea what calculate area function did, I could ask for help on it. And what does it show? It shows exactly the stuff that shows up in the doc string. That could be useful. You see, I can ask for help on anything. Okay, help. We've used print all the time. What if we forgot what print does? Or what print does? Well, it's help on built-in functions. It says right here that the print looks like this. And it prints values to a stream or to system out by default. Okay, that is correct, but you have to start to understand what is sys.standardout. That's the console, actually. And it takes the following arguments. You see, you can pass in a file. I don't know how to do that. Oh, but we've seen this before. Sep and end. Yeah, we've seen it. The instructions are actually right here. Yeah, it has everything. All right, some other things that we've done. Okay, unfortunately, I can't clear the screen of this one. All right, remember that we have a bunch of stuff from math. You can import the library, and then you can say, okay, give me some help about the math functions, and okay, now it says squeezed, so unfortunately in Python, or in idle, I have to double-click this. Here you go. You see, there's a bunch of functions in here that are inside the math function, like for example, there is a dist, which is a Euclidean distance between 2 points P and Q. So now you can actually go and you can learn how these things work. Okay, yeah, but of course, maybe you didn't even know it was there. Oh, and if you say, yeah, but can I use it over here? And the answer is mostly. Okay, sorry, a couple of things don't work in our online interpreter, so if I can import math, I can then ask for help on math, and yes, it will actually give this to you. So there's a lot of stuff that's built in, which is very, very handy because a little bit later, okay, is there a function that can tell you whether or not all of the characters in a string are uppercase?
Is there one?
Yeah, is there one? That's what I'm asking.
Yes.
Yeah, are you sure? How do you spell it? Yeah, IS, is it an underscore upper? Or is upper?
Is upper. Like
Yeah, but the only reason why you know that is because you probably had to learn that in the other course. All right, so remember, this would be help on strings. All right, so what we can do is we can go through and see, is there something in here? So center, count, encode, ends with expand, tabs, find, format, index, blah, 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 blah. Is ASCII, is decimal. Okay, here you go. There's something right here, is digit. Yeah, good. So you can see how this works. Now, unfortunately, sometimes it's a little hard to read this stuff because it looks like it takes a parameter called self. That just means that it's the name of the string followed by a dot. You have to learn how to interpret these things. But yeah, everything is here. And no, this is not cheating on a test. Okay, so if for some reason you need it, by all means pop this thing open. Some things don't quite work the way that you expect. Like you can try a bunch of things. Yeah, this is help on the integer, but you might not find it all that useful. Okay, it's not the greatest thing. Sometimes students complain saying, yeah, but it's pretty limited what it provides. Yeah, but it's at least something. But what you can see is that it is very, very useful if you're writing a big program, you have a lot of functions that somebody else wrote. And you say, how do I call that function? Do I have to call another function first before I call this one? That's why each of these functions that I provided today, I did exactly the same thing. Okay, sorry, as I picked the one that I didn't do. There you go. Yeah, I included a doc string here. I included a doc string here just to give you the idea that yes, this happens. In this course, this is a requirement as part of the coding guidelines. If you ever write a function, you have to provide a doc string. Now, the good news is because I tell you exactly what the function is going to do, you pretty much get the function, you pretty much get the doc string for you. Yes, you can copy and paste it, but yes, it is a requirement. Do we get marks for it? No. If you don't do it, it's a penalty. Yeah, so you want to do it. Okay, not because you're getting marks, but you don't want to lose a mark for not doing it. And yeah, the lab instructor is supposed to be checking that. All right, let me just check. I think that everything is finished, but I just want to make sure that it's not like another page. Yeah, okay, that's fine. And, oh, there you go. Are the doc string is important, and the answer is yeah. Remember what I've said this before, I hate to call them do real programmers out in the industry write comments? And I said, not much. Okay. However, do they write comments on their functions? And the answer is yeah, they do. Okay, because the functions become the main building blocks of the overall programs, and without some description about what the function is doing, you're not actually helping anybody. If it's your own program, okay, fine, you don't need to write comments for it, but if it's going to be a function that's going to be used by other people, it's really, really critical to do, and that's why we kind of push on this one. Okay, so this does become really important, and yes, we do kind of expect it. All right, so there you go. Yeah, we already learned we don't want to look at the answers to those MCQs. So here's your challenge at the MCQs at the end of each slides. Look through them and find the errors, because there's probably a bunch in there. I mean, we found 2 or 3 in the first one. So I'll leave this as an exercise for you guys. All right, so we're done a little bit early today. I promise to hold you extra time next class. Okay. Anyway, see you next week.